In this video, I would like to speak about infrastructure as code, Terraform, and Bicep. What are these things and which one should you learn? Infrastructure as code means that you define your infrastructure in files as code so that you can reproduce them very easily. So this is what infrastructure as code looks like in Bicep. So you define a resource in your code. In this case, it's a key vault. And then I have a parameter of location, which is the same as the resource group. But here I'm creating a key vault called Misha138 with these parameters. And then when I run this, it will be deployed in Azure. So that is the main principle of infrastructure as code. You can define something in code, and then you know exactly what's going to be provisioned. Now, what are the advantages of this? Well, for one, your infrastructure becomes reproducible. So that means that you can tear down all of your infrastructure and then redeploy it, and everything will be the same because you have everything defined in code. Secondly, you can create templates or modules. So if you have a certain set of resources that you want a development team to have, for example. So for example, we used to have a set of resources that would contain a cluster, it would contain a key vault, it would contain entries in the firewall, etc. You can create this whole package, and then you only have to enter the name of the team, and the rest is going to be rolled out automatically. So that's a very powerful feature of infrastructure as code. And lastly, another very important feature of infrastructure as code is that you get version control on it. So you can track the changes in your infrastructure through the code. So you would have this code in a Git repository, and then if you're working with several ops or DevOps engineers, you would create pull requests to that repository, and then you can audit the changes that one another does. So you can review the changes that your colleague wants to do, and you can point out, hey, maybe that's not a good idea, or maybe we can improve this. And then when that's done, you can also trace back in history what has been done earlier, like if a mistake happens. So that's a huge advantage of infrastructure as code. And what is the alternative to all of this? Well, that is when you go into the portal of Azure. Portal of Azure. And then you go into, for example, virtual machines. And you would create a machine, and then the virtual, you create it like this, and then you give it a name, etc. And then the resource exists in Azure. Now, like if you're just testing or trying something out, this is not a problem. But there are companies who have been doing it like this, what we call click ops. So people just click in the portal and create resources, but then there's no central way of managing that. There's no way to reproduce that. So whenever you work with cloud resources, always try to do it from infrastructure as code. There's one principle that I would like to give you. So that is the concept of infrastructure as code. And now Bicep and Terraform are implementations of that. Bicep and Terraform. So let's talk about each of these. So Terraform is by HashiCorp, and it's multifunctional. What do I mean by that? You can use it in different clouds. It's cloud agnostic, and it's even tool agnostic. So you can use Terraform to provision cloud resource in Azure. You can use it to provision resources in AWS, but you can also use it in, for example, Proxmox. If you know what Proxmox is, it's like an operating system to create virtual machines, and you can use a Terraform provider to do that. Likewise, Grafana. If you have a Grafana cloud instance, for example, you can provision teams and dashboards and all sorts of things through Terraform providers. So Terraform is not only for cloud infrastructure, although that is its main use. You will find that there are more implementations that you can do with Terraform. Now, it's very often used in conjunction with AWS, but Azure also has a rich set of Terraform providers, and I'll get back to that. Now, Bicep is Azure only. Bicep is created by Microsoft as a domain-specific language, so it can only be used on Azure. It is created by Microsoft. It is maintained by Microsoft. Now, there are a few benefits of using Bicep if you are a Azure-focused professional or company. A few benefits are, Bicep is developed by Microsoft, so you always have access to the latest APIs. So whenever Azure makes updates to their resources or they introduce a new feature, then it is updated in the Bicep APIs. However, the Terraform providers, so I'll speak to providers after this, but the Terraform providers are community-driven. So Microsoft does not officially support or contribute to Terraform providers. I should rephrase that. They do contribute to them, but it's not that Microsoft is incentivized to do so, because HashiCorp is a different company. Now, there is a thing called Azure Verified Modules, which I've already created a video on, but which I will expand upon in a later video. And in there, they do have create Terraform modules. Now, what is a Terraform provider? Now, if you go to Terraform Azure, if you go to the Terraform registry, this is a list of providers. And a provider is basically an interface that you can speak to, where you can define resources, and then Terraform translates that to the actual API of the cloud provider. So the cloud provider has, in the case of Azure, it's called the Azure Resource Manager. This is an API to which you will send JSON objects fundamentally, and the ARM then converts that to Azure resources, like to virtual machines or Kubernetes clusters. So the Azure Resource Manager is an API that takes JSON objects through it's a REST API, and you can basically talk to the Azure Resource Manager through JSON by post requests if you wanted to. But a Terraform provider is an abstraction above that. Now, there are many different providers. Like here's Azure. There's also Kubernetes provider. And as you can see here, maybe there are a few more, like a Helm provider, Nomad, Boundary. So there are tons of Salesforce. There are a lot of different providers that you can use. But these providers are community-driven. They are open source projects. So when a new feature comes out on an Azure resource, then it's immediately updated in the Bicep API, but you are then dependent on the open source community for that to be implemented in the Terraform provider. And from experience, I know that this does not happen quick or frequently. So many things that you can do in Bicep are not supported in Terraform, or at least not yet supported in Terraform. So if you choose Bicep, then you always have the latest features, and you know that everything is up to date in according with the Microsoft ARM APIs. So that's one very important thing about Bicep. A disadvantage of Bicep is that you learn this, but you can only use it on Azure. You can not take this with you to other cloud providers. Now, I don't see that as a problem, because I basically pick one cloud provider and I stick to that one, and there's enough work in that, so I don't worry about like locking into Azure, because I'm fine with locking into Azure personally. Like I would rather have one provider that I know well, and to use their domain-specific language to know that I know well, so that I can do great things with that, right? So that's just my take on it. Now, another big difference between Bicep and Terraform is the fact that Terraform uses a state file, and Bicep does not. So what does this mean? So Terraform keeps a state file where it will basically store all of the state, all of the things that are currently available in Azure, and then it compares that with the code that you write. So if I say in the code, I want one VM and one AKS cluster, I'm just making something up, one VM, one AKS cluster, then Terraform is going to check, hey, are these things in my state file? Are my things available in the state that I know about? And if they are, great, I don't have to do anything. If they're not, then Terraform will create those resources to make sure that the state file matches the code that you write. Now, problems arise when you have a friendly engineer who then enters the portal and starts making changes in there. And if someone, for example, changes the disk size of a virtual machine, and then you start working with Terraform, and then you change the IP address, I'm just making something up, but if you change that, then suddenly your state file is messed up. So your state file does not match what is in Azure anymore. So it doesn't match anymore. So either Terraform is going to fix that, but most often, if you make manual changes in Azure and then it doesn't match the state file anymore, it will basically break. And this, in my opinion, is a nightmare to manage. Like, I don't like working with Terraform because of this reason, especially if you have multiple people deploying from the same state file. So usually you would do this in pipelines, but it is also possible to do it locally, for example. And this state file would then be stored somewhere in a storage account. But if multiple people are working with this, and for example, you do something simultaneously, oh boy, you can get into real trouble with that. And I've worked with Terraform extensively. I've worked with Bicep extensively. And for me, Terraform has been a huge headache. And that's probably because like I know it can work. There are plenty of companies that make it work well. So I'm not saying that Terraform inherently is bad. I just haven't worked in an environment where it has worked well. And I know several senior engineers, 13 plus years of experience, who have told me that they share my experience across different companies that they've worked in as consultants. That Terraform basically always is a nasty experience to work with because of these problems. Bicep does not have this problem. Bicep simply looks at the state in Azure, and it will have your code file, and then it will just create the resources that it needs to create, and otherwise it won't do anything. There are different modes you can use in Bicep. There's mode incremental, which does this, but there's also something called mode complete. And that means if you have a file with code, which contains a resource group and then all of the resource in it, if you do mode complete, then it's basically just going to brute force creating this every single time if it doesn't exist. And it will overwrite everything in the resource group. It will just brute force, like, this is the state we want, create it, boom. Usually this is not used, but you can do it this way. But the mode incremental, this way, is the generic way to do it. And it works really well because either you make the change or not. So what you do is you create pipelines with the infrastructure as code, which run periodically. So you do it like every hour or something, or every day. And that way, if someone comes along and makes their change in the Azure portal, then their stuff breaks or their stuff gets overwritten. And then they come knocking at your door saying, hey, I changed this and now it changed back. Why is that? And I say, well, that's because you're not following the process, and we actually should do it from the code, because then we know exactly what's going on. And if an engineer gets this answer 3 times, then they won't do it anymore, and then they will do it the proper way. Now, of course, in a proper setup, a person wouldn't have this option at all to change these things, but that's a discussion for a later day. So in my experience, Bicep has been more pleasant to work with in Azure. Now let's take a look at the code. What does this actually look like? So I have found Bicep to be a very intuitive language, very easy to learn, very nicely structured in JSON-like objects, and it's very, very easy to learn. For example, an AKS cluster looks like this. You just define the resource, which is called manage cluster. Then you give it the API version, and then you give it the name of the cluster, the location, and then you set certain properties. And then if you don't set it, it will get a default value generally. Some properties you have to set. But for example, enable role-based access control, you get a prefix for the DNS, and then you add a node pool, and that's it. It's really simple, nice, and intuitive. And Terraform is practically the same. It just looks a little bit different, has a little bit different syntax, and it uses something called HCL. I think it's the acronym for HashiCorp language. So it's not, both are just as easy to learn, basically. But Bicep might be just easier, actually, now that I think of it. Bicep is easier to learn, but Terraform has a wider application. But both are, it's not difficult at all to learn this stuff. Like people try to make it out as super complex, but it's not. It's actually super simple. You can learn it in an afternoon if you really put your mind to it, to at least get your first resources deployed. Now, now the question is, which one should you learn and how do I learn them? Now, I would say learn both. Both are important to know as an infrastructure engineer or DevOps engineer, but focus on one, I would say. And the way you figure out which one to focus on is simply to look at the job postings where you want to work, look at the companies where you want to work, and base your decision on that. So if I want to work, if I need to find a junior DevOps position, if I were in that situation again, I would look in all the job postings for Azure that are on my level, and then I would see, is the majority asking for Terraform or is the majority asking for Bicep? And I would base my decision on that. Now, don't weigh it too heavily because all of these skills transfer to one another. If you learn Bicep, you know Terraform for 80%. And if you know Terraform, you know Bicep for 80%. It's very transferable. So you can't go wrong, basically. In order to learn them, in the case of Bicep, I would highly recommend doing the Microsoft Learn. They have complete courses on this. Let's see. There is the fundamentals of Bicep, intermediate Bicep, and advanced Bicep. I think that's the, let me see. Yeah, this is basically a complete course for free with Bicep, with practice environments, the whole shebang. You have everything you need here to learn Bicep and to learn it well. If you go through these modules, you're ready to deploy, you're ready to start working with Azure and infrastructure as code. Seriously. So in this course, these courses are for free. Just learn them and it's all you need. And what I recommend is then creating a lab repo like I have here. And I have my Bicep here. And here I have tons of files about Bicep. And then as you're learning, you commit that to your lab repo. And then that way you also build up a bit of a code repository for yourself that you can then refer back to if you want to. So I would learn Bicep this way, do these courses, commit all of the code, and practice in your own Azure subscription. Don't just do the modules, also try to think of your own stuff. So if you have learned how to do virtual machines, well then think, well, maybe how do I deploy an app service, or how do I deploy an AKS cluster, for example, a Key Vault. Try to think of your own little projects and go beyond the course, basically. And in terms of Terraform, I basically learned by doing. Terraform has great docs, but they do have a Terraform certificate. Let me see, find the right certification. Here, Terraform Associate, that's it. So here, this is a free learning path. And then you can learn everything about infrastructure as code, how Terraform works, etc. It's pretty easy. And then in the end, you can get a certification. And then you also know enough to get started with Terraform. And with Terraform, you might want to check out YouTube if you can find a free course, maybe on Udemy. I don't have any resources to recommend actually on this particular one, because I think Bicep is a good way to go if you're going for Azure, and the learning material for that is available for free. So, but there's tons of free Terraform resources available too. Like you don't need me to tell you what to search for. There's not really a certification for this, but enough resources to learn. And basically it's learn by doing and building up your own lab environment and expanding that in complexity as you go along. Bicep also comes with very good IDE integration. So I do it in NeoVim, but if you use VS Code, it has very good IntelliSense and it has all of the APIs integrated. So it's a very, very comfortable editing experience as well. So that's what I would do to learn infrastructure as code. I personally would check out the job postings, see what's available and what they're asking for, and base my decision on that. But if you're planning on working with Azure, then I would highly suggest learning Bicep. It will take you maybe a day to do a few days to go through all of these modules, and then you know it. You can put it on your CV. You have the code in your lab repo to prove it, and you're off to the races. Because fundamentally, like I said, Bicep is basically just a templating language that all Bicep does is, let me see, Bicep. All Bicep does is it takes these little objects that you define, and underwater, it just turns them into Azure Resource Manager templates, ARM templates. ARM templates are the old school way of doing it, basically just pure JSON that you would write. And Bicep is just another layer on top of that, that basically transforms this into JSON and then sends it to the Azure Resource Manager API. And so if you learn Bicep, you will also get a much better sense of how the Azure Resource Manager works. And you get less of that when you use a Terraform provider, in my opinion. Let me know in the comments which one you are going to learn and if this was useful to you. And remember, I have my school community, which you can join if you need help with learning this, if you want to ask questions to professionals who know this stuff, if you need some help with direction in what to take your career, or if you want to have access to all of my courses, check out my community. I think you will like it. So thank you very much for watching and see you in the next one.